Here we're asked to approximate the area under the curve for the function negative x squared plus 6. I'm going to go ahead and sketch the graph here because this question asks us to use 4 rectangles to approximate the underestimate. And I'm not sure if that's left or right just by looking at it. But when I see this, this is a negative x squared graph, a negative parabola. So we really get this shape that kind of looks like this, and we're only looking between x values of 1 and 2. So throughout that whole time, our graph is decreasing. And I'm going to zoom in kind of on that area there. If I see something that is decreasing, well then if I want an underestimate, that's going to have to be right endpoint rectangles, because because right endpoint rectangles are the ones that give me this extra little space inside the graph there. So this one here is going to be right endpoint. The next one's going to be an overestimate, which I'll do in green here, which is going to be left endpoint rectangles. And the last one is going to be in sigma notation. I'm going to reverse the script on this and do sigma notation first, because there's some stuff I can do by creating the equation before I get into actually like multiplying all this stuff out. But in this one here, sigma notation, right, I'll start with the right endpoint rectangles. I'm going to say k is 1, and it goes up to 4 because we're using the right endpoint. Then I'm going to say the width of the rectangles, because I'm going from 1 to 2, and I'm breaking it into 4, I know that each piece is going to be 1/4 wide. That's going to be my width here is 1/4. Or 0.25. Doesn't really matter how you want to write it, decimal or fraction here. I recommend if the fraction or if the decimal isn't like a perfect decimal, like if it goes on forever, then use the fraction. But in this case, we got 1/4. Then my height is going to be the original function, which is negative x squared plus 6. But instead of x, I'm going to plug in the function for x sub k, which in this case here is going up by 1/4 each time, because that's our width and starting value at 1. So here is my right endpoint sigma notation. Now to actually do this math here, I'm going to be plugging in these x and y values and multiplying them, because that gives me, the width and height of my rectangles to multiply together. So I'm going to go ahead and write this out, plugging in some numbers, right? And then I will actually calculate. So here are all of my areas of the rectangles. So first one, second one, third one, and fourth one. I'm doing 4 rectangles. So once I go through and I add all those together, I get an answer of about 3.281 is what I will call it. Again, depends on how you round sometimes, but 3.281, I'm going to call that, a good approximate there for the right endpoint. Now for left endpoint, I'm going to do pretty much the same thing here, except, for the overestimate, I would say. But instead of using, the last k value where it gives us the, final x value on the right, I'm going to instead use the first one where I just get 1 on this side here. So I'll rewrite it. So now not using that last one and only using this one, and then adding all these other 3. So my rectangles are now 1, 2, 3, and 4. And when I add those all together, I end up getting about 4.031. Again, this is an estimate, 4.031, depending on how you round and all that jazz. So hopefully that's about the right answer for those. So overestimate and underestimate depend on if it's decreasing or increasing. Our sigma notation is always going to be the same. Doesn't really matter. The only thing that changes is that if we're using left endpoint or right endpoint, our starting and ending k values change. But that's all 3 of those parts of the problem.